Oh gosh. Look at these integrals. It was great. That's awesome to hear. Okay, so this, I think, is one where we can jump in here. I don't know if they're asking for help on literally all of these or what, but they have the integral. Let's start with just number one. The integral of tangent to the fifth times secant to the fourth. These integrals are usually super obnoxious. If we were to do u equals tangent theta, we would cancel out a secant squared. Let's investigate that angle first. Gauss identity? Does that have another name? I haven't heard of the Gauss identity. E to the I theta? Oh. Euler identity. Okay, that makes more sense. I don't think... Normally we don't involve complex numbers in like a calculus class like this. Hey, Jed. Why so melancholy? Oh, the music? I don't know, I just felt like having some piano music on, I guess. To me, it's more just like calm, I guess. Hey, Pen Center. I don't know why I was about to just call you Pen, but... E? Or I guess there exists. Oh. Well, I'll see you after the ad break, Jed. I guess it's the only ad break for the entire stream. It's unique? Oh, there exists a unique. I didn't know the exclamation point meant unique. And I do proof so little that I forgot that the backwards E is there exists. Oh, okay. So I think you're saying that the music was melancholic because of the piano. Then he switched on differential equations. Yeah. I was literally just saying before the raid that there's very few math questions out there for me to do, so I might just look for a differential equations problem for fun. But we do have some integrals, and those are also fun. Well, I mean, this particular integral is more annoying than fun, but there are like pre-made rules where like if you have an odd exponent and an even exponent, you do the sub, but I can never bother to memorize that. I just try things and see where they go. So I want to start with u equals tangent x, because that would mean du equals secant squared x dx. And let's just see where that leaves us. We'd have u to the fifth, which we might not want to make all the tangents to use. I'll just do that though for now. Secant squared will partially cancel with the secant to the fourth. So we get secant squared x dx. Now secant squared, thanks to a certain Pythagorean identity. Is that 1 minus, or no, I think it's 1 plus tangent squared. Should really quite this week, finals people. Yeah. So I've been thinking, even like next week, I'm probably just not going to bother with the math stream. It's going to be Christmas week. I doubt there's going to be much for me to do. 1 plus tangent squared. Thank you, Jed. Okay, yeah, I think this is the strategy here, because now that's u squared, and we get a fairly easy to do integral out of this. Why did I put dx there, by the way? So we get u to the 6, 1 6, plus 1/8 u to the 8th. 1 6 tangent to the 6. X, it's an x, I promise, plus 1/8 tangent to the 8th x plus c. Don't forget your c. Perfect time for Penn Center and you rematch in Super Mario Bros. Oh god, yes. I would love to be able to catch that because I missed the last one. Oh, with the DX Jed, yeah, I didn't see that at first, but I happened to catch it. Wait, there's still a problem? Secant squared x? 30 minutes jumping on the same note block? Oh god. Oh yeah, Jed, that's because yeah, it's okay if you do that. You can't actually integrate it until everything's in terms of u, but your u sub doesn't instantly have to resolve everything. Like in this case, we had to use it in identity before we could get everything in terms of u. So yeah, it's okay that as long as you don't actually go through with the integration, you don't have to do it. Oh wow, that's not what I wanted. Whoa, okay, I'm gonna stop playing with it. Oh, no, I did it again. What? Oh, I'm holding the Windows key, not Alt. That's why. Dude, I'm freaking. I'm not. I haven't had a single drop of alcohol, and I feel like I'm drunk right now. Hey, Bob. Oh, dude, new emotes. Nice. Oh, no one jumped on that first. Thunderfix was here at the very start, but I assumed Thunder's on even points and didn't want to be on odd points. So you're busy watching ads? Are you asking about all of these? For the first one, I'd recommend you u equals tangent x. Because it came the way? Yeah, so I don't know how Thunder knows, because I never see the full value of my points either. It's for a bit. Did another 30 plus hour awake with 1 hour sleep? God, Bob, you need sleep. Hope you're able to get some. Oh, if you hover over, you see? Well, for me, I literally have infinity channel points in my own chat, so that doesn't mean too much for me right now. I'll have to. When you wake up, sleep schedule is back to being whack. Okay, infinity odd or even? I think both at the same time. Okay. Let's start up with this and see what happens. It is 45 minutes after they last posted in this thread, so they might not still be around, but we'll see. Parkour. Camel and banana problem? That sounds like the setup to a joke. A camel and a banana walk into a bar. Oh, what? Eat the camel and save the bananas. Wait, okay, minors of a matrix? Nah, this is. I'll let Penn Center do this. I don't know that stuff. Modify quick math to include prime. I have to do factorizing. Are you gonna make me factorize like something with a lot like 48? I mean, I guess that could be fun. Okay, I'll try it, and I'm sure that you or Spetchy or someone are gonna find a problem that'll make me regret that, or Boodib. I'll update it right this heckin' instant. Where is it? Viewer rewards, channel points, manage, quick math, addition, subtraction, multiplication. or prime factorization with no more than 2 digits. There. Now make me, I'm sure you'll find a way to make me regret that. Try to the prime factorization of the UPCs and the shit. Aren't those like 10 digits? Jen, you're a nerd. I'm sorry. Yeah. Factorization by parts? Oh, I haven't even heard of that. I mean, I guess you like keep dividing by 2 or something if it's even. Oh, parts of the UPC. Okay, okay. What's the question here? That My Little Pony was very majestic. Thank you, Penn Center. Oh, I got to solve a Rubik's Cube? All right. Let me get the timer up. All right, my fingers are cold, but let me warm them up. Ugh. All right, let's first scramble it. Down prime, left prime, down 2, R, L2, D2. Is that back prime? No, I think that's back prime. No, that's back prime, I think. I don't know. Who cares? It doesn't matter. It's all scrambling it. All the backs and downs, dude. I don't like doing them. Okay. Inspection time. Oh, wait. Oh, that's not... Oh, never mind. Hey, dude, I'm not... Okay, thank you. Jeez. It's clicked into the URL bar. My fingers are still cold. Where the frick is that? Okay. Oh god, a J-perm? Okay. That could have been a much better time. Oh well. New PB? No, my personal best is like 17 seconds. I got very lucky in that solve though. Like I got to skip a bunch of steps. My average is more around like 25. Calculate the number of Rubik's Cube positions? I don't know how you begin that. I don't know how you instantly know it's prime. There must be a trick, I guess. Oh wait, okay, so this person... Okay, so they got an answer up there, and they're now asking about 71. Oh, the trick is Wolfram Alpha. Okay. That's a nice trick right there. So asking about 71 here. Okay, so yeah, you take the derivative of each and you equate them. So you'd have at x equals 0. So you'd have a equals 2x minus 3. You plug in 0 for x and you just get a equals negative 3. And if a equals negative 3, these two functions are equal, right? That's important too, I guess. Of course, they're both going to be 0 at 0. Okay. I get negative 3 for the answer as well. Just mirrored the bear have 2 heads. Yes, it does have two heads. It's because if you notice on the very bottom there, it says New California Republic because it's from Fallout New Vegas, the game, where that's like a faction in that game. So it's not but it is almost like the exact same as the California state flag, but it's like a spoof of it that the game used. And I both live in California and I love that game, so it felt kind of perfect. If I didn't live in California, I would have gotten like the Brotherhood of Steel flag or something. Use Mathematica to generate it so the cheats can. Oh, I assumed that was just the UPC code or something, honestly. You just randomly typed in your keyboard. You know, we could keep working through that one person's integrals. Because there might be some more. I mean, I guess, yeah, that trig integral was kind of fun because it wasn't that much work. At least this person's honest. I don't think they're gonna have much success with this, but I appreciate that they're being upfront about what they want, I guess, rather than trying to trick you. Doesn't this look like this looks like the logo, like, is it Quiznos? What is the Quiznos? There's like the green and red. Sorry, I'm getting distracted all the time today. Quiznos. Or it's like, isn't, why, I'm hitting enter, why are you, okay. Oh yeah, it does look like the Quiznos logo. I don't know what the heck that is, but flag of Italy. Oh, that's probably the more cultured thing to associate it with. Oh, well, I mean, you have to like rotate it, but yeah. Oh wait, I might be the bot that's posting. Let me solve the integrals if possible. I didn't even see that. Oh, that's so mean. What the hell? I didn't even see that. If possible. Like, I was wondering how you would do this one, to be honest. It might be a trick with the bounds. It is root 2 to 2. U equals 2x squared minus 4. Would that cancel the x? I guess you could re-express the denominator. You'd have root u over something that's a little, like, complicated. It could be I could see it being a trig sub. U equals 2, no, u equals root 2 secant theta, or tangent theta. Okay, you know what? You tempted me. Let's try it. Doing that one. Okay. Root 2 is sus for a trig sub? I feel like it's not too uncommon. So we have the integral from root 2 to 2 of root 2x squared minus 4 over x dx. So I'm thinking the Pythagorean identity we want is, I assume it's going to be tangent squared minus 1. No. Wait, I'm being dumb. Why do I know how to apply these, secant squared minus 1 is the identity we want? Okay, so we want u equals root 2 secant. Okay, yeah, secant, okay, yeah. Thank you, Zach. We need root 2 x on hypotenuse, 2 on a leg. Where's Stookie? Got fucking many. Hey, hard luck. Thank you so much for the 4 months. Astro. Well, if hard luck wants to be first, hard luck it can be first. So, okay. Hope you guys are both doing good today. So I'm saying we should do u equals root 2. And thank you again, hard luck. I appreciate you. Root 2 secant x. Yes, okay. So du is root 2 tangent x secant x dx. So we get root 2 to 2. 4 secant squared x minus 4 over root 2 secant x times root 2 tangent x secant x du. No? Wait. Du, yeah. Why? Okay, that's why. I was like, why is everything in terms of x still? Wait. No, that doesn't work. Why am I, did I switch I switched the x and the u. Oh my god. X equals secant u. Oh my god. This is bad. U. I don't know. So, okay, well, these should all be u's. Right? I'm gonna check chat in a second because I'm sure it's melting down. Okay. Hard luck the liar. I knew Don before he was born. Yeah. Things are going great. That's great to hear. Back in the meantime, you just annoy me. Okay. Let's solve that Rubik's Cube quick for Astro. Then I'll get back to the integration. You can finish the problem? It might take a lot more work, so I and this will only take me like 30 seconds if I can talk. Okay. Make sure I'm clicked in. Inspect. Okay. 26 seconds? That's a lot better for me. Okay. You need to learn to solve one? I mean, I mostly just learned in high school because I was really bored during class and my teachers wouldn't take away the Rubik's Cube. They do think I'm texting all the time because I was just like this underneath my desk, and they'd be like, "Put your phone away," and I just hold up the Rubik's Cube, and they'd be like, "Oh, never mind." I always wondered, what are you doing during the inspection phase? I should be doing a lot more. I tend to like look at it and then forget about it. But I'm basically just planning how I'm going to do the first like step of solving it. Just how we can do it like a bit more efficiently. Because the very first step is pretty like flexible. That becomes tangent squared and it gets rooted, so it's just tangent. Oh, we have to integrate tangent squared, dude? Who knows how to integrate tangent squared? Oh wait, no, that's not that bad. Because tangent squared, we put it back in secant, that's kind of funny, is secant squared minus 1 is the exact same. And secant squared has a known antiderivative. So 2 tangent u minus 2u with some type of bounds once we... Oh, I shouldn't be using the same bounds when I do the u sub. That's bad form, but sue me. Oh wait, no. I can't do it like that. Exactly. Put your phone away. Yeah, exactly, Astro. Zone, yeah, you're right. I mean, I normally just don't write them until I unsub. And then I'll like start to write them again. But I could also just change the bounds and not unsub, I guess. There were notes of the calculating Rubik's Cube thing. Oh yeah, I should be making much better use of my inspection time, but CV step at the end. Yeah, in this case, it probably is worthwhile changing the bounds, because I'm going to have like tangent of arcsecant, and I don't want to have to draw a right triangle. That's a good point. Okay, so if x is root 2, that means 1 equals secant u. Secant is 1 over cosine. So just over cosine is equal to 1, which is at 0. So u equals 0 for our first bound, I hope. And then if 2, is root 2. Wait. Why did I just forget about the root 2? I'm just making the math problem easy. Oh wait, no, the root 2, no, that was fine, because the root 2 is canceled. Ugh, okay. So the first one is u equals 0, because the root 2 cancels the root 2. But then we have 2 equals root 2. Dude, I'm sorry, my brain's all over the place today. 2 over root 2. Is that even... It's not just root 2? And if you were to flip both sides, it'd be root 2 over 2 equals cosine u. So our upper bound is pi over 4. I hope that's right. That feels right. Okay, so then we just evaluate this from 0 to pi over 4. Tangent to pi over 4 is 1. So 2 minus pi over 2. That all zeroes out. So 2 minus pi over 2 is our final answer, I think. That's a negative number, isn't it? No, it's not. Okay. Let's check back on the Discord. So I think the person has just left because they haven't posted anything since. This does technically save you work, but if you're doing this problem blind, I don't think you would know to do that. Like, I would only know to do that stuff with the benefit of hindsight, so they are right, but it's kind of hard to give that advice to someone in general, I think. So we could keep working through their integrals for fun, but let's see if there's someone who's still around who might need help. Consider g of x equals minus log x by x minus 1, f of x equals minus. They're the same thing, okay. It is the case that f of x equals g of x, right? They have different derivatives, mainly g prime x equals 1 over 1 minus x. Oh, never mind. It's x minus 1 and 1 minus x, and they're gone. Okay. Does f of x equal g of x? See, I can factor out a negative sign. So yeah, you can definitely manipulate them to get them to look the same. Or no, would you be allowed to do that? Because when x is a variable, you can't just wholesale get rid of that negative sign, can you? Oh yes, sorry Bob, I saw you post that, and then I think I was doing an integration, so I didn't have time to actually like understand it. But as long as you got your answer, that's the important part, I guess. Oh wait, I'm sorry, for calculating the permutations of Rubik's Cube? Or are you talking about... Oh, I see, yeah, you're talking about the permutations for a Rubik's Cube. Compared to just 2 wild, yeah. For just talking to yourself, well, that's cool. I talk to myself all the time. I make great conversation, so why wouldn't I? Okay, I actually am a little bit, like, if I just do... I just want to, like, because I'm not exactly sure what the deal is with that absolute value thing either. So absolute values, for me at least, they can be kind of tricky sometimes with stuff like this. It's an interesting graph. I guess it makes sense that it'd be mirrored. They do look the exact same, so maybe you are allowed to factor out a negative sign and chop it off. But you have modified the original function that you were given, I guess, which is why their derivatives are still different. Okay. All right, Bob, sleep well. That's an order. You have to sleep well. There's a new post in Sneak. Okay, I think they just dipped out though. What are they asking here? Oh, how to use this formula. I mean, the problem just says to keep multiplying by 4. There isn't really a much better trick than what they did. Just to have the same formula. Determine the explicit form of the geometric sequence represented by the graph. That's kind of mean not to get, like, they cut off the graph there. I feel like they should show the 50 mark. I guess it is technically shown, but like, okay. Well, our initial numbers are going to have to be 48, and it goes from 48. I mean, even that, I don't really like it, because like, you can only know that that's 48 for certain by looking at the possible answers here, which I don't really like, but know that when x equals 1, we're expecting a very high number, somewhere between 45 and 50, and 48 is the only one that fits the bill here. And so when x equals 1, so immediately the first one and the third one are out. When x equals 1 and the second one, you do get 48. In the fourth one, you also get 48. I mean, I can already tell that we're decreasing here, so we're going to go with the second one, while this one is going to be increasing. But just to drive the point home, let's try it with 2. When x equals 2 here, we get 48 times a quarter, which is 12. That matches up with the graph. Here, we get 48 times 4, which will get even higher, and it'll go way off the graph up here. So, you plug in x equals 1, and then x equals 2, and seeing which ones match the graph. I'll try seeing items you plug in x equals 1, x equals 2 to the possible answers, and seeing which ones match the graph. Okay. What was this person asking? I don't know. All right, so this person, okay, so they posted their screenshot. Okay, to get k so that function is positive for each x with a greater than 0, d less than 0. Y equals k minus 4x squared minus 2k minus 2 plus k minus 4. So k minus 4 is greater than 0 from the first piece of information there. Capital D. Oh, discriminant is less than 0. Okay. You know, that is a tricky situation, isn't it? So they get k is greater than 4 from the first piece of information. And from the discriminant, it's b squared minus 4ac. So k minus 4 is less than 0. So they get 4k squared minus 16k plus 16. That seems like the correct multiplying out for that first part. Minus... Oh, these are the same thing. Nearly. Basic. Actually, yes. No? Kind of. Wait, aren't these... Wait, these... Are these... So you can split the form into 2 by 2, or 2 times 2, and put 1, 2 in the first one, 1, 2 in the second one. They'd have the same thing with the signs flipped. I know, either way. I can factor the 4 from this and check like that, I guess. Actually, I guess they're not the same. That's weird, though. I don't know why I can't do math today. I need to change my Twitch name. K squared minus 8k plus 16. Oh, I'm getting beaten to the punch here. I assume that they just made an arithmetic mistake here, but that person seems like they're saying that it just isn't, like, this problem isn't solvable, or that there's no k that satisfies the conditions. Maybe that person thumbs me up. Oh, well, they said the question hasn't been resolved. But I wish they said why, or I wish they asked me something back. Oh well. We can still do some of these integrals for fun, I guess. Let's bring this back up. So x squared plus 1 over x squared plus 2x plus 3, that factors to x plus 2, or x plus 3 times x plus 1. No, x plus 3 times x minus 1, but it's all squared. You don't get a cancellation there, do you? Is this just a really mean partial fractions problem? I think it is. No, wait, I factored that wrong. It's x minus 1, or yeah, x minus 1. No, that doesn't even factor. The sign isn't right, is it? X squared 2x 3. Okay, yeah, it doesn't factor. It's just really mean partial fractions. I'm not doing partial fractions right now. Unless someone needs me to do it, I'm not going to do partial fractions. For this one, this feels like there's a trick here. Do you multiply by maybe 1 plus e to the minus x? Or maybe you multiply by 1 minus e to the x? Or you can change the numerator to be 1 plus e to the x minus e to the x. And integrating e to the minus x over 1 plus e to the x is potentially easier? Question mark? There's a lot of possible things you can try here. I don't know which one is the best one, though. I just looked at the one below, and that looks really mean. So does the one below that one. Actually, that one, I feel like that has a known form, or there's some kind of like known trick that you can do with that form of I forget what the name of it is. You have 1 over something plus sign. That has like a specific name, I feel like. But let's see if we can figure this one out. Might it be possible? I kind of want to explore it for myself and see. Why are you? Oh, right at the wrong end of the marker. Okay, so at first I was thinking that doing plus e to the x minus e to the x is a good idea. But the more I think about it, the more I don't think that's going to help. So let's try multiplying. What do I want to multiply by, though? We did 1 plus e to the minus x. Let's just see how that looks. Or should I make that a minus? Let's just see how this looks, to be honest. It's going to be 2. 1 times 1 plus e to, yeah, so we get 2. Plus e to the x plus e to the minus x. That doesn't clean up how I thought it would. If we multiply that by e to the x times e to the x, what happens there? I'm just really trying random things right now. Does that factor? It does factor, doesn't it? Wait, I get the same thing back. Never mind. I was about to go in a big circle there. Conjugation. That probably is it. It's a neat trick with this to simplify it. What is it? Because I just went in a big circle here. I remember you were doing problems just like this like last week, right? So yeah, we could do 1 minus e to the x. That's one of the ones that I was debating too that might be helpful. The 1 minus e to the 2x. Well, that doesn't give us a u sub though, does it? Circle time? Oh, there probably is a way to make a circle with this. Conjugation and trig sub with exponentials. That scares me. Multiply the top and bottom by e to the minus x? Okay. That makes me not feel scared. Let me try that. Right? And then do you do u equals e to the minus x plus 1? And then you get over u. Ah! And that's just minus ln u. Ln me. And I don't think that really simplifies, does it? Plus c. Okay, yeah, that's a nice trick. I didn't see that there would be u sub like that with e to the minus x. Thank you, Dan. Did I do something wrong? Mathematica says x minus log. Oh, really? I've never gotten a math problem wrong before, so I can only assume that Mathematica is wrong. You can find common denominator. Oh, it turned out to be the same thing? Oh god, Jeff, no, don't ask me a math question now. No, I don't want a Jeff math question. I shouldn't have tempted you. Okay, Wolfram Alpha at least agrees. Wait, no, that's x minus. Wait, I did do something wrong. Change the e to the minus 1 to 1 over... Wait, this is right? Wait, so maybe I didn't understand. This turned out to be the same thing? It is right. I don't know where the extra x comes from in this way. I guess I could let's see. Okay. Oh, you get partial fractions with that. Or, I mean, it's a really simple partial fractions, but... Cool. In my solution. So you turn that into 1 over, like, at the very final step here? Or is I thought I did something wrong up here. Okay, so you're saying yes to when I said down there. But yeah, Jeff, no, I don't know the evil GIS stuff. It scares me, so I'm sorry. You're right about that. Oh, you get it. Oh, common denominator. Okay. And then you're saying that becomes e to the x over e to the x. Oh, haha. Then you use a little log identity on that. Okay. Logs are so tricky. That one got me. So you have a, see, it does become plus x plus c because there's a minus sign out front. Simplest answer sign is the best answer. Yeah, I mean, I definitely, like on a test, I would have just sent it at the step that I got to. Calculus variations. I don't know calculus variations either. Okay, you know what? I've been really bad about adding saves. That's a save for Dan. That's a save for Penn Center. Ah. Evidently not. Nightbot doesn't like that. There we go. Yeah, I mean, there's some math questions that I straight up will tell, like, the student were like, you know, technically we have the right answer right here, but your teacher might mark you down for some reason if you don't simplify it a bit further, so you might want to also do this. It's a little bit annoying, but sometimes it makes sense. Sometimes it's just, I don't get it. You see there's a new one here. Oh, it's already getting worked on. Okay. Wow, only 4 things open in the math help Discord. People are not doing math. Flappy's all over the help this week. Okay. Yeah, sometimes people just like go in streaks of like getting in every channel. Which, more power to them, I guess. So we can just keep on going with these integrals. Today's the solstice. Tell us how to calculate it. I mean, I think it's over for, like, I don't know. I feel like Europe does their own weird thing with, like, schooling, but everyone at least has, like, a week off for Christmas, I would think. I was saying earlier that I don't know if I do the math stream next week or even on Saturday, it's probably not going to be, I'm probably not going to do as many as I usually do, or I'm just going to make it more about like studying or something. How do you calculate the solstice? Like figuring out what day they happen on? Solstive? That's definitely... what I wanted to say there. It's at 8:28 p.m. MST. This is a bunch of big words, dude. What is a JD? Julian date? Oh. That would make sense. I don't know how this works. I don't know how to spend a bunch of time just like figuring it out. I definitely couldn't do it on my own. Oh, dang it, Jeff, you're trying to trick me into doing your math and I have no idea how to even start it. That's kind of funny, honestly. I hope you're asking Zach the same questions. I saw you in his chat. You know, if you're gonna torture me, at least torture the other math streamers too. I do want to look at this this one with the fractional powers of t. So that could be a fun one too. You multiply it through by like curly the unbearded one. E to the 2i pi. I have a feeling for this fractional, like you multiply through by t to the 6th or something. Calculate the perimeter of an ellipse, then yell at you for consulting Google. Classic Jeff right there. Perimeter of an ellipse is not like as easy as it should be either. Like, I don't think it's one clean formula. Like you have to use calculus or something each time. I think. I remember having a problem kind of like that before, and it wasn't as simple as I thought it'd be. It's not as fun to trick you if you go to Google. Yeah. There's always a Bessel function or something. Okay, yeah. So if we have dt over t to the 1/2 minus t to the 1/3, I think we multiply through by the least common multiple. I always get mixed up with greatest common divisor, but least common multiple, 2 and 3, which is 6. T to the 6 times t to the 6. Wait, they're going to add though, aren't they? That doesn't make sense. That's what make it turns into whole numbers. Okay, immediately I now want to throw out what I thought you could do for this. Can you have to raise it to a power, but even, what the heck? Maybe you conjugate this one too. Multiply it by the plus version of this. That could work out. Let's see, I thought I knew how to do this one. Now I'm not sure. So t to the 1/2, t to the 1/2 becomes t. The term in the middle will cancel. Minus t to the 1/3 plus t to the 1/3 minus... Oh, that's not... Wait. 2/3. That's not what I hoped would happen either. Maybe there's just some crazy u sub. Do you just do... Oh, wait, maybe you do, you start out with a u sub. Maybe. Possibly. Don't you do t, like u equals t to the 1/6 or something? And then that's t cubed and that's, or u cubed and u squared? That might be it. The if possible part of the original prompt is still kind of scaring me, but... I'm not even going to apply the u sub yet, besides the, I'm not going to like plug in things right there because I want to get cancellations first if I can. Or not cancellations, but combined terms. Okay, so t to the 5/6 times t to the 1/2 is t to the 8/6 which is 4 over 3. T to the 5 over 6 times t to the 1/3. It's t to the 7 over 6? And actually, I don't want to simplify that fraction. I want that as 8 over 6. du. Now we can do the u sub? 1 over 6, 1 over u to the 8th minus u to the 7th du. What the hell? 1 over u to the 7th u minus 1 du. I guess you, like, is that just normal partial fraction? Do you have to do anything fancy? Like, I feel like the u to the 7th, with partial fractions, when there's a repeated term, what do you actually do when there's a repeated term? I can't remember now. Oh yeah, oh god. Oh, it's gonna be a super ugly partial fractions. That's like 1 over u to the 7th, unless there's a trick here that I'm not seeing, but it's gonna be like a over u plus b over u squared plus c over u cubed plus d over u to the 4th. Oh god, there must be a trick here. Gotta go all the way down to h, dude. Who wants to go down to h with partial fractions? Like, unless it's just like a shortcut you can do off the bat. Like, Wolfram Alpha, that's a good shortcut, right? Not really math. What's the shortest string you can go that will yield 0 results? Surely a single letter, right? Well, I guess you wouldn't want to search like X. That's going to be like Twitter. Like, if I just search Q. Never mind. I mean, I don't know. Should I just... It must be some random string with like 3 characters then, maybe. I don't know. I don't want to... I feel like if I just start Googling random things, something horrible is going to come up. Every single letter is technically a dictionary word? Oh, wow. Okay, I want to make Wolfram Alpha do those partial fractions. U minus 1, I said? That's our partial fractions. I'm so glad I didn't do that. Film's better than The Room. I never actually seen The Room. I know people love it. You only know the memes? Oh, okay. Like the I did not, or whatever. So I've heard people do that meme, and I think it's from the Room. Yeah, okay. Well, I'm that's just a meme. Okay, is there a different trick entirely? If I gave Wolfram Alpha, actually I want to give it this version first, and then I'll give it the original. Wait. 1/2, 1/3. Actually, no, I was giving you my version. No. It was x minus 1, wasn't it? Yeah, it was. It doesn't actually make that. It doesn't really make that much. Oh my god. Nope. I don't think there's gonna be a trick. Yeah. Nice. Now a trick that Wolfram Alpha sees. 1/2 to the 1/3. Really? That's a lot simpler. Wait. Why did theirs work out so much nicer? Mine didn't work out that nice. Oh. Did I do a wrong step here? May have done a mild oopsie here. Yeah, I didn't negate the exponent. Or I did the wrong thing with the exponent. So the thing I did wrong is that t to the minus 5 over 6, I forgot to actually solve this equation for dt, and that should be du. So that exponent is going to flip to be positive when it comes over there, and I didn't actually do that flipping. Same thing with the 1/6 in front. Let's say, like, that partial fractions is way too mean to give to a calculus student. Well, to give to anyone, really. Yeah, what I should have done is said 6t to the 5 over 6 du equals dt, and then plugged it in. I just like to be cool and do that in my head, and then fail at it and complain when I fail at it. So you get t to the 5 over 6 over t to the 1/2 minus t to the 1/3 du, and then I'll plug things in for u. So that's u to the 5th. That's u cubed, right? Yeah, minus u squared. Okay. Then you can factor out a u squared and cancel with the top, so you get u cubed over u minus 1 du. Now you could do u cubed plus 1 minus 1. And the sum or the difference of the two cubes will give you a cancellation. I feel like I did something wrong again, though. No? Okay, I don't remember my formulas for the cubes, so I need to look that up. I use it so rarely that I don't have them memorized. So we want a u minus 1, so we probably want the difference of two cubes, to be honest. Difference. X cubed minus y cubed equals x minus y, x squared plus xy plus y squared. Okay. That's going to be our trick here. So 6 u cubed plus 1 minus 1 over u minus 1 du. And I'm going to take the u minus 1, or u cubed minus 1, over here. U minus 1 plus 1 over u minus 1 du. That, the top factors to u minus 1 times u squared plus u plus 1. Right? Right. You get u cubed plus u squared minus u squared plus u minus 1. Okay, good. Yes. The u minus 1's cancel, and then you get a much easier integral. U squared plus u plus 1 plus 1 over u minus 1. Okay. And the rest is history. Okay, that's a fun one too. I forgot to turn the cam off, but I think I'm going to leave that particular integral there, because then it's just like busy work. I got the idea. Okay, so that person, they're still not replying back, so I'm not really going to post anything. Let's see what's up here. I was going to do one of these modeling with a sine or cosine. So the period is 12 hours. At low tide, the water is 4 feet deep, and at high tide, the water is 8 feet deep. Depth of water is currently 6 feet and is falling. Use this information to answer the next 3 questions. Okay. Are they posting where exactly they're stuck? 11 they got C, 12 they got A, 13 they got D. Are they right? Let's see. So they got C for part 11. So the phases are all pi over 6. So that's nice. I don't have to worry about the whole, like, it has to be 2 pi over the period. I always forget that formula actually goes inside the sign. That's taking care of us. So it basically has a midpoint of 6 feet, and it fluctuates by plus or minus 2 feet. So that's why we have a coefficient of 2 for all these, and a plus 6 on the outside. They surely have parentheses, but it's okay. Not parentheses police, even though I just kind of was. And we're currently at t equals 0 at 6 feet and going down. So they're saying it's part C, because when you plug in 0, you do get 6. Which part A does not have. When you plug in 0, you get 8. Part B does potentially work for t equals 0. Part D does not work, so you get 4. So we narrowed down to B and C. How we can figure out between B and C, the only difference is the minus sign, so let's figure out, I mean, we can tell intuitively that if we're currently falling, we're going to need this minus sign here, because sine starts out as positive. And you can plug in, sine would reach its first peak normally at pi over 2. So you can plug in t equals 3 and get 1 for sine times negative 2 is 6. So at the first peak, or at least it'll be a valley at 4. So yeah, I agree with C being the answer here, because we expect to reach a valley at our first kind of like critical point. And part C fits that bill, whereas part B does not. What's blue and destroys your teeth? A blue brick or candy, whichever is funnier. I like having the options, Bootib, thank you. Okay, so I agree with them for 11. For 12, they got A. The water in the bay will be 5 feet deep at which time? So you take your answer for part C and make it 5 equals this equation and solve it. So you subtract the 6 to get negative 1 equals negative 2 sine pi over 6t, divide by negative 2, and you get 1/2 equals sine pi over 6t. Take the arcsine of 1/2, and you would get a number, that's for sure. Pi over 3. No, pi over 6. And then you would multiply by 6 over pi. So your first one will be at t equals 1. You do have to, because arcsine isn't defined ever, you do have to, like translate the angle. So 5 feet deep is kind of below our midpoint at 6. And we said that it's going to start off by going into a valley and coming back up. We're starting at 6 feet, so as we go down into the valley, we'll hit 5 feet, bottom out, come back up and hit 5 feet again. I mean, already, I said that we found t equals 1 as the option, so it just has to be part C. We don't necessarily even have to check the other answers because that'll include 1 hour as an option. So actually, yeah, I mean, just right. Wait, A. If you plug t equals 4 into that, you get sine of 2 pi over 3, and who the heck knows what sine of 2 pi over 3 is off the top of their head? I sure don't. I'm not in my trig class anymore. Square root 3 over 2? So that's certainly wrong, right? For answer A. We don't expect an irrational. Yeah, you're right. Thank you, Jeff. Oh, no, I'm sorry. Like, the answer the person got is certainly wrong. You're right with the root 3 over 2. It's positive root 3 over 2. It's in the second quadrant. Okay. Yeah. So when you plug in t equals 4 for this, you get minus root 3 plus 6. That's definitely not equal to 5. So the answer should be C, because sine of pi over 6 we said was 1/2. So that gives you a negative 1 plus 6, which just come out to be 5. So actually, you don't even need to do the algebra thing that I did. You can just plug in the possible answers that they give there. So I disagree with their answer for 12. It should be C. For 13, thought it was 60 degrees. Did the wrong calculation to get the right answer. Nice. It works out, you know? The water in the bay will be 8 feet deep. I mean, this is the exact same type of question, I guess. So, for when t equals 3, you get sine pi over 2, which is positive 1. Which gives us actually the opposite of valley. So we get 4. At t equals 0, sine of 0 is 0, so you just get 6, so it's certainly not B. At t equals 6, you get sine of pi, which is negative 1, which is what we want. Because you get negative 2 times negative 1 is positive 2, plus 6 is 8. Let's make sure that 9 doesn't work as a sanity check. Sine of 3 pi over 2 is, oh yeah, it's down there, it's negative 1. I forgot. I thought I was getting my fraction mixed up. I should have known that. Sine of 3 pi over 2 is negative, wait. Oh no, sine of pi is 0. Okay, C does not work. Okay, it should be D. They got D, okay. Try plugging t equals 4 into minus sign, or into the equation you've got for 11, and you'll see it doesn't come out to be 5. Okay. Ashkar 6S, welcome in. Thank you for the follow. Tomorrow you're doing an exam, you got stuck on a question, you got an idea to look on Twitch, and got you. Can I ask the problem? Yeah, sure, please do. You can type it right there in chat, or if it's easier to post a screenshot, I have a Discord. Whichever you prefer. Yes. You're more than willing to just type it right there in chat. In the meantime, I'm going to keep looking around on this Discord just for other questions, but as soon as you... Oh, okay. Determine if the function, I assume it's even or odd. F of x equals sine x plus cosine x. Okay, we can do this. So do you know generally how you test if a function is even or odd? It involves plugging in a negative sign for x. By your calculation, you thought it was odd? Okay, I'll try it for myself and see if we get the same answer then. So our original function is f of x equals sine x plus cosine x. So I'm going to say it's neither, and I don't know how they got it. Yeah, I just by looking at it, I assumed it would be neither because sine is odd and cosine is even, and when you add them together, I don't really know what you get. So basically, the test that we do is we plug in negative x everywhere we see x, and we see what it comes out to be. So f of negative x is equal to sine of negative x plus cosine of negative x. Now we have to use some trig identities here. Like I said, sine is an odd function, and we have an odd function of a negative number. You can pull the negative sign outside. So sine of negative x is the same exact thing as negative sine of positive x. And cosine is an even function, and for even function, you basically get to ignore a negative sign on the inside. So instead of pulling the negative sign out, we just get to ignore it. So cosine of negative x, same exact thing as cosine of x. And here, we don't really get anything that matches. If it's even, we expect to get the same exact thing as our original function, and we haven't because we have a negative sign there, and that's a difference. Or, you know, that means, you know, we haven't gotten the exact same thing out, so it can't be even. And how we'd say that, like, mathematically is that f of negative x is not equal to f of x, so it's not even. And now for odd, we'd expect to get, for both of these to have negative signs, basically, because I can even show it. We expect f of negative x to equal negative f of x. And negative f of x, if we go back to the original function, is negative sine x, because you have to distribute a negative here, minus cosine x. We haven't gotten that either. So in this case, we have that they're not equal to, so it's also not odd. So I hope that makes sense. It doesn't fit either criteria for even or odd, so we just say it's neither. You got it? Okay, glad to hear it. Hey, Enigma, how's it going? Got it wrong because you thought... Show some unit function, odd function is neither even nor odd. Or find a non-constant counterexample. Just ignore the sine and cosine and just solve for x. I'm not sure exactly what that would entail, but that sounds like the wrong track, so... I definitely would just do it the way that I said, with trying to match it back with the original function in some way. Trying to solve that for x is going to be very weird. No worries at all, Ashkar. I'm here for the people who are into math, so if there's anything else that I can help you with, please feel free to ask it. Show the sum of an even or odd function is neither even nor odd, or find a non-constant counterexample. Like a whole test you need to solve. You're allowed to use outside help for it, right? I should probably have asked that, but as long as you're allowed to use, you have barely 4 out of 10. Oh, okay, so you've already taken it. Dang. Yeah, as long as it's something where outside help is allowed, please feel free to ask away. And Jeff, that is an interesting problem. Do you know the answer to it, or are you just like trying to phrase that question generally? I'd assume it's going to be Neither even nor odd, always. But I don't know. He just made it up. Okay. Yeah, that is an interesting question. I mean, we could look at that. I assume there's going to be some kind of a. I assume that's been a problem that's been worked out, right? Oh, Ashkar, you don't need to worry about this. We're just interested in like generally if you add an even in an odd function, can you prove something about what happens there? So you don't need to worry about like what we're talking about right now. We're just asking like generally how you would prove stuff. Well, like this. um, Talos. Yeah, we just did a question about even and odd functions. And I guess I'm gonna go back to looking for more questions now. Ashkar, if you have anything else pop up, let me know. Hope you're doing good, Talos. They seem hard. Can I see two more for even or odd? Yeah, sure. Please do. It is a very weird like concept, I guess. You do it on Discord? Sure. There's a math questions channel at the bottom of the list where you can feel free to post it there. I'm also excited for code names tomorrow. I need to make an actual like announcement for that somewhere. Yes, Dookie, I was just thinking about that. So people have said yes. Are you, Talos, Penn Center, Zach, Jed Levi, me, which is 6, which is kind of like the minimum that I wanted. Dan is maybe, No Pro Bob is maybe. And I think that's everyone that I invited. We could throw out more invites too if we wanted. But that's at least who I had thought to invite. What time are we doing this again? 6 p.m. Pacific. Okay, so I'm thinking that we can just meet in my Discord as well, because I don't know who else like Penn Center, so yeah, 6 p.m. So I hope that works. Okay, so yeah, I see. I'll just copy it down from my Discord. I don't think I need to get the actual image on screen. So we've got two more even and odd functions here, or two more functions. We have to determine if they're even or odd. Let me copy them down and then we can work through each of them. So our first one is f of x equals x sine x over 1 plus cosine x. Interesting. Our second one is f of x equals 2 to the x plus 2 to the minus x. Do you need to download anything? No, it's all through their website. So you don't even need to make an account either. Like I made a little like quick session just with I opened a few browsers on my own computer, just like test it. And it was pretty simple. The airport speed has been garbo the past couple days. Oh no. All right. Well, I appreciate that, Talos. I hope your internet clears up. That's really annoying. Okay, so let's look at the first one here, Ashkar, I guess. So we'll do the same thing as we did last time. Oh, wait, and Buddha, you're asking what you people doing? Oh, I thought you were just like, this was greeting at first, but I was confused because you were already like typing. We're gonna play a game called Codenames. it seems super fun. I haven't actually played it for myself before, but I've seen it. It's like a word association game where you have like a grid of words and you have two teams. And you have to give like one word clues to try and get your team to choose the words that are your team's color. It seems like a really good time. Okay, so Ashkar, looking at this one over here first, I guess. Let's do the same exact thing as we did the last time and find f of negative x. So x will become negative x. Sine of x will be sine of negative x. 1 plus cosine of x will be 1 plus cosine of negative x, like this. Now let's apply our same trig identities that we did here and here. So sine of negative x is negative sine of x, but we also have a negative sign already here, so negative times negative is positive, so they just go away. You just get x sine x on top. And cosine is even, so we get to get rid of the negative sign entirely. And look at that, we've gotten our same exact function back out. So because f of negative x is equal to f of x, we would say it's even. And if you want to be really sure, actually wait, no. I was about to say if you want to be really sure, you can check if it's odd, but we already know that's not odd because there should be a negative sign in front if it feels odd. So does that make sense for the first one, Ashkar? Yeah, okay, glad to hear it. Let's look at this exponential one then. So let's do the same exact thing with looking for f of negative x. 2 to the x becomes 2 to the negative x. And 2 to the negative x becomes 2 to the negative x, like that. So the first two just kind of, we can't do much with it. But the second one, we have a negative times a negative again. So that flips to being positive. And if you'll notice, we actually do the same thing back again. We can make it even more obvious, and we can switch these twos around, the twos around. 2 to the x plus 2 to the negative x. It's just addition, so you can rearrange them as much as you want. We have the exact same thing back out again, so we'd call this function even again. We have an even amount of even functions. Look at that. Perfect, Ashkar, yeah. Negative times negative is positive. What about 2 to the x minus 2 to the negative x? Shouldn't that be the same thing, even? Oh no, it would be, oh okay. Yeah, it would be odd then, Jeff, right? So just for fun, because, yeah, Edmund was right. If we were to look at a flipped around version just to get an odd function in there, and Ashkar, you don't have to pay attention to this if you don't want. You didn't ask this question, but if we were given instead 2 to the x minus 2 to the negative x, we can just look at that to get another example. 2 to the minus x minus 2 to the minus x. 2 to the minus x minus 2 to just the x. And now we nearly have the same thing, but not quite. So this one actually does a little trick where I'm going to factor out a -1 from this to make it clear what's happening. So that 2 to the x becomes positive. I'm going to write it first. That 2 to the negative x becomes negative. I'll write it second. And in this case, if we did have a minus sign instead, we have the same exact thing, but there's a minus sign stuck in front now. So that one we would say is odd. So now we have an even number of even functions and an odd number of odd functions on the board. Gonna fail your Stump the Streamer class? Thank God. You've been doing too well in that class, Jeff. That might be the first question you've ever asked me that I can do. Yeah, thank you for the questions, Ashkar. If you still have more, feel free to keep them coming. If not, I'm going to go back to what I was doing. I'm going to solve the whole test for you if you're bored. How long is it? Like 5 more? I mean, if they're in the order of like, or if they're not like 6 more, if they're about the same amount of work as that, then I guess so. I'm just gonna parent. I'm gonna make the disclaimer. You know, as long as you're allowed to use outside help. But 6 more isn't too bad. They're not the same. Oh, like not necessarily like the same like type of question, but like as long as they're not like you know, just post your questions, I guess. And if they're all like super long word problems, then maybe I'll just do like a few of them of each type. But I'll definitely like take a look. Oh, it's in you. Okay. I can sometimes figure it out just by the math that's happening. But if there is a translation, then that's probably helpful too. um, well, the sneak person never did get back. It's kind of a shame because these integrals are kind of fun. The given surface as an iterated double integral in polar coordinates and then find the surface area. Ooh. The portion of surface z equals xy that is above the sector in the first quadrant. But z equals xy, that sounds like some kind of funky looking parabola. Above, bounded by the lines. Oh, God. I'm gonna look at this one a little bit. I mean, I'm not gonna actually do this one because I'm gonna focus on Ashkar's test, but I'm kind of curious what that function looks like. Z equals xy. Double integral, yep. I do love some double integrals and triple integrals. They're just fun. We weren't really interested in the... Oh! I think this would look kind of like a rotated parabola, but I didn't even think about the whole negative part. It's almost like if you took a parabola and like bent 2 sides of it down. We're mostly just interested in this part though. Because that's the first quadrant, or first octant. Did they say quadrant? Oh, let me so we have some posts in the Discord. So this person for the sine and cosine problem asked me if it's C, right? Perfect. I got C as well. It's a Pringle. It is a yes. That is a Pringle chip, isn't it? I mean, I guess that's kind of a saddle point. Any type of saddle point, right? Okay, let's look at what Ashkar posted. Let me make this a bit bigger. Well, wait. So you're asking about 6? And 7, it seems. I'll bring up the image separately. I'll see how, of course, he gave all since Pringles and doing saddle points. I like that. 6, first two monotonic, second two intervals of two monotonic functions to get the point of the question. Let me... Okay, so you're given these two functions and you have to prove that they're monotonically increasing or decreasing. Center. They're almost all on mute, but a lot of these are just like DayZ discords and stuff. But I had to put them in folders like this because it's a lot. 1 minus x cubed. Yeah, like I just like, I don't like the bottom here, mostly just like bots or like string elements or stuff like that. So I don't actually check all of these that often. Hypobolic probability. So these are just the questions, Ashkar? Like not your work on them, right? Okay, so you posted this too. About 10. Okay. Interval. I definitely know that, Ashkar, about function composition. It means it's the same as f of g of x, if you've seen that. Vacuum them SMB street. All right. Enjoy Penn Center. Six seconds has two intervals of monotonic. So yeah, I see what you mean. Like for these two, it's two intervals. I can see that the functions. Is this like a calculus class, or have you not done calculus yet? Out of curiosity. Because there's definitely a calculus way that you could do this question, but I have a feeling that you're not in a calculus class. It's the beginning of calculus? Okay. So what I think the question seems to be about, if we have y equals 1 minus x cubed, just to prove. Okay. So how do you prove that it's strictly... So I think they're asking you to prove that it's strictly increasing or strictly decreasing. 1 minus x cubed is strictly decreasing because when you go from left to right on the graph, your y values are going down. With calculus, this would be like 2 steps and then you're done. Without calculus, I'm not sure how you do this. So I hope I'm not going off the deep end here. But I'm trying to think of a non-calculus way to prove that this is always decreasing. And the only thing I can think of right now is plugging in x plus 1 into this function and comparing the results. I don't know if you were given a way that you're supposed to do this. But if you have f of x is equal to 1 minus x cubed, if we looked at what happened if you added 1 to x, same thing as doing x plus 1, could we show that this function is always less than this function? Because we know that 1 minus x cubed is something like that, and that this just represents a left shift by 1. So it's going to look like that. And that's always, this second curve is always less than that curve. Hey, Bikara. That might be a better way to do it. Because I think this way it technically kind of works, but I don't like it. Where it's one critical point. That's true. It does zero out just for that one point, but it's not increasing, so I think you're okay. So, Ashkar, what's being said in chat, which I think is probably a better way, is just to say that make the claim that x cubed is always increasing. Actually, I guess that's when x equals 0. That is kind of a tricky situation. Is increasing strictly greater than 0 or greater than or equal to 0? I guess I'm saying always increasing rather than always strictly increasing. Or no. The wording here is a little bit tricky, but the point that they're making is that just x cubed on its own is it never fully changes direction. So if you have minus x cubed, it should always be decreasing. I feel like the wording isn't quite perfect. And it's also something where I wish I could see an example problem from how you've maybe done in class. Because this feels like there's a couple different ways to make this claim. Let you take a look? Okay, thank you. Because I think there's many different things you could do with this question. I just don't want to do something you haven't seen or that your teacher wouldn't like. It is increasing there too? The derivative, the calculus method fails though? Oh, okay. The next one would be ln of x minus 1. So we can just bring in the graph of that for fun. Ln x minus 1. So this one is also going to be, this is a bit more clear cut because you don't have that little like zeroed out point. But I still don't necessarily know how you show that. You have it for other exercises, but not for this one. Ah, dang. Oh wait, looking at Discord, are you Ashka R6S, like Rainbow Six Siege? Can I send you the others? Yeah, sure. Or should we call you Ashka or Ashkar? Yeah, sure. Okay, BC Aura. That's funny. For the first thing you put, your name wasn't capitalized. Okay, I guess I'll call you Aura. And Ashka, okay. Or if you press BC or something. No, I don't play Siege. I've seen it though. It's weird. Those first time chats, like the color of the name is usually wrong, and then I'd never seen the capitalization be wrong, but oh, you just changed it. Okay. Well, sorry if I butchered your name enough that I made you change it. Welcome in though. Thanks for being here. And for inverse of e to the x for the ln question, I mean, the inverse thing is sure. I don't know how, like, just because a function is increasing, does that mean its inverse has to increase too? That is the case here. I just don't know if that's a real thing, or if that's always true. Send you in DM? Oh, no, you can put it in the chat too. I don't care. There's not too much else that's happening in that chat right now anyway. I'm planning to switch it over to a different thing too, so things are a bit more like separated out. You did in the chat? Okay, thank you. All right, that's true, Jeff. Okay, so let's look at this first one that you sent. I haven't heard the term invariable before. Oh, invertible. Okay, I was like... It makes sense, just as like the consequence of being reflected across y equals x, but there might be some weird counterexample or something. I'm not sure. So this one seems like a similar. You actually have one from 6? Oh, okay. Oh, wait, this is the one? Okay. Obviously, yeah, it's like it's probably like a pre-calc class if you're just starting to do limits here. So if I don't want to rely on calculus stuff unless it's something that you've done. Hey Ben, meth, yep. So it's just using the properties of a parabola. Really? What is the, or why do we need the minus b over 2a? I gotta solve a Rubik's Cube? Okay. Isn't that a formula for a? The t. Wait, I'm not sure what this is, to be honest. I don't recognize this. I'll do the Rubik's Cube in a second. The vertex. Oh, that's what you're finding. I think so, yeah. So you'd have to complete the square. Oh, I see. That was just to find... Okay, so this just seems to... That's right. Yeah. I see the t there now. I was kind of glazing over it. So, okay, so this one is where you just find the intervals where it's increasing and decreasing, and we've already accepted the fact that a parabola increases then decreases, or decreases then increases. So I'm not sure how we get to that fact for like the first two questions there. I can help you do like the questions after that, I think, from when I quickly looked at it. I might not be able to help you with those first two though, for how you'd actually prove it. Let me do this Rubik's Cube solve quick. But I'm also just like thinking about it more anyway. Wait, it's like that. I'm just scrambling it right now. I'm not actually solving it yet. Okay. And then inspection time. Ah. Oh no. Ah. That could have been a bit faster, but it's not a bad time. I'm kind of rusty on it too. Can I solve one side? I was gonna say really bored in high school. And so I just like grinded it a lot. Cube only has 6 colors. I do have one with more colors, a 12-sided cube. Or not cube, but mega mix or whatever it's called. Okay, so I'm really not sure how you go about doing this first part. No balls. It's gonna take me too long. It takes forever to solve, so I didn't want to do a redeem for it. It takes even longer, but I also have this. It's like a Rubik's Cube with 7 rows for 10K. Oh my god, no, it's gonna be so boring to watch. Just like I'd approve these first two without calculus, and they're always increasing or always decreasing. So, like the rest of these, actually, this first one is just what we just looked at on the worksheet that you did in the 6th dimension. Yeah, 12-sided cube. Yeah, I don't know what the actual term for it is, but. So, actually, I think it is actually basically what PC Or was saying, where if we can already take x cubed as always increasing or always decreasing, 1 minus x, or x cubed is always increasing, and so 1 minus x cubed must always be decreasing. That doesn't feel like much of a proof to me. And what Telstich is saying too, like the parent function of this is x cubed. And sticking a negative sign in front of the x will means that you flip the increasing versus decreasing. So x cubed is increasing, negative x cubed is decreasing, and the 1 doesn't change anything. And I guess for part B, you would make a similar argument that ln of x is always increasing, and that the -1 is just a right shift of 1 and doesn't affect the increasing or decreasing. So I think it's the best answer I can give you without having like been there in the class for myself too and knowing how the teacher exactly wants it. How many times can you subtract 57 from 97? It need not be, that's division. No, Bridget, that's the same example that you gave me. That's, no. That's the same. I need to change the phrasing even more. No, I did do it on stream, and I was about to. No, I already refunded it. I did do it. Moody asked me the same question earlier. No, earlier I used to have division before, and Buddha gave me 57/97, and it's a repeating decimal, but the pattern is like 90 digits long. I was like, oh, I'll just try and get the pattern, and then that's the answer. And then after like 4 decimals, I was like, okay, what the hell? There's no pattern, so I gave it to Wolfram Alpha. The average slope from 1 to infinity is positive. Slope never changes signs. That's possible, yeah, like doing the calculus argument without doing the calculus argument. No, I specifically took out division because of boodib. So yeah, Ashka, I'm sorry I don't have a more satisfying answer for these first two. Sound like a skill issue? I guess so, yeah. I'd rather do your complex variable guess method for differential equations than 57 divided by 97. Oh, and I did realize that's called undetermined. It's just like a fancy version of undetermined coefficients. That technique does have a more commonly known name. The last one, 6 exercises then? Yeah, that's what I was thinking, Ashka, that we can just move on to this part, because I don't have a good answer for you than that, or a better answer for you. So this first one, that's actually what you showed me on the worksheet here, right? It's the same problem. So is there something that you didn't get, or do you want to see the second one? And you don't need to worry about the first one. 6 is the intervals of increasing and decreasing, I think. So since we have parabolas, we have basically to find the vertex. So, okay, Ashka, you said yeah, but I asked you like a million questions at once without pausing. So I'm going to assume that you are good with the first one unless you tell me otherwise. I have a really bad habit of doing that. Like I'll ask you one question, pause for a second, then I'll ask like 3 more questions, then I don't know what you're responding to. 66 plus 44. I'm about to say 100, but that's 110. That one I can do. Wait, yeah, it is 110, right? Yeah, 110. Okay. A cool trick to find the vertex. So Ashka used like just minus b over 2a, which I'm pretty sure just works. Is there a better trick? Should the applied method seem to be struggling? Yeah. You know, today I've been doing the math all wrong, so I think my degree should be revoked. Okay, so first I'll make a note. The x squared is the important term here, and it has a minus sign in front of it. So it's going to be some parabola facing downward somewhere, but it's facing down. That's the important part. It's minus b over 2a, but there's a nice easy proof. I mean, it's basically just like completing the square with vertex form. The x coordinate, yeah, tells teaches. And that's all we need for the problem for intervals of increasing or decreasing. So if we apply the formula here, b is 2 over 2a is negative 1. So we just end up with positive 1, because 2 over 2 cancels. Yeah. So we know the x-coordinate of this vertex is 1. We don't care about whatever the y-coordinate is, just squiggles. So we would say the function is, for this part, increasing from negative infinity to 1, and decreasing from 1, that's not a comma, is it? To infinity. And at 1 itself, it's neither increasing nor decreasing. Shift the whole parabola so the constant term is 0. The original is shifted about the same. X value. Oh, that is cool. I didn't think about that part of it. Wait, 12 cubed? I shouldn't say exponentials. I don't know what 12 cubed is. 144 times 12? Look, that's actually not that bad to do, right? Because 144 times 10 is 1440. And then you do plus 24, which is 14... Oh god, I already lost track of my numbers. 1440 plus 24 is 1464. Plus 1 is 1465. Oh, there's a formula for the sum of cubes. You're right about that too. Is it 1465? I think it's 1729. What the heck is 12 cubed? Oh, 1728, obviously. Okay, well... plus 288. Oh, I did 2 times 12. I should have done 2 times 144. That's... okay, I can't do mental math. Okay, I'm sorry, Ashka, that I'm like all over the place right now, but... Are you good with the parabola? Yes. That's 9 cubed plus 10 squared. If you do the formula for sum of two cubes, I was literally just looking at it, but I forgot it. 19. 81 minus 90 is negative 9. 91. 19 times 91? You want 9 cubed at the top of your head? Oh, I don't. Actually, you only need to get 9 cubed, because the 10 squared is easy. So 9 times 81 is 9, 72, 729 plus 100 is 829. Damn. Wait, you said 10 squared. There's a squared in there. You were uncorrected. Oh, I didn't see that. Okay, well, 1729 then. I did solve the original one, right? So I'm taking those points. Okay, so Ashka, we're working on the part 7 now. So we need to find f of g and g of f, it seems. Is what the question is asking. Let me, I'll show it on the screen. I didn't realize I wasn't. So assuming that's the entire task, just finding f of g and g of f. I'll show you what the notation means, and I think you'll understand what's happening. Because it's much more common. I mean, I see them both pretty commonly, but well, the notation that makes more sense to me is f of g is the same thing as f of g of x. It's called function composition, and same with the other way around. All the O means is, oops, this is all the O means. And I'll show you how we actually like compute that. Oh, I keep on forgetting to take the cam down. You had a question after this if you're down? Yeah, I mean, we're kind of working through Ashka's test, but if you want, you can post the question or like DM it to me or something, and depending on how long it is, I'll either do it on the spot or afterward. Okay, so Ashka, for our first question, we're given f of x is 5x minus 4, and g of x is 2 minus 3x. So if we need to find f of g first, I assume we need to find both here, but working first on f of g, oh my god, I keep on doing that. Fog is equal to f of g of x. Basically what this means is we take our f of x, and wherever we see an x, we plug in g. So it's going to be 5. Now x becomes 2 minus 3x minus 4. And then we can simplify that, and that'll be our answer. And Fibonacci of Fibonacci, I'm not even gonna look at that yet. You sent it on Discord? Okay. Oh yeah, there is the explicit formula, right? I guess you could use that. So I'm gonna simplify this. 5 times 2 is 10, minus 15x minus 4. So you get 6 minus 15x. So that's our answer for f of g. Hey, Mangoes. And so Ashka, g of f is just the reverse. We have g on the outside now, and we insert f of x. So our g of x is 2 minus 3x. So 2 minus 3. Now instead of x, we have f. 5x minus 4. You can simplify this again. 2 minus 15x minus plus 12. That's horribly wrong. Oh my god. Plus 12. It's equal to 14 minus 15x. So those are the two answers for the first part of 7. Does that make sense now that you've seen it, Ashka? Let's look at what Ben sent me. Seems fun. Glad to hear it. Absolutely awesome. Wait, Ben, I've done that exact problem before and it was painful. I have done this on stream, I think. I think after a certain point I called it quits and used Wolfram Alpha. It's so much algebra. No, I'm not doing this question. This is the devil. You like the answer to the problem? Did I do a slightly different version? It's a 4-minute vid? Maybe I did a slightly different version of it. Or that vid skips over all the hard part. No, it was this one. Shows every... No, I've done this. I think someone posted this question somewhere as an, like, it made it look like an honest summer question, so I gave it a good try. And it was... You get the most annoying things to factor. Because I multiplied by the same thing, but with a minus sign. The answer is good? I don't remember getting a good answer. Maybe I did the wrong first step. I don't know, man. I'm gonna do Ashka's next one, because if you want to give me the first step here, yeah, if you can give me a hint, then sure, but it, like, I know I tried the exact same problem before and it did not work out. Check Discord. You do a substitution. A plus b equals x, so a squared minus b squared equals x, a minus b. I multiply each side by a minus b. So oh, and if a plus b equals x, then a equals x minus 1 over, okay. A squared minus b squared equals x minus 1. You will love the answer as a mathematician. I don't know where you go from here, though. So, well, I guess you would unsub. Okay. Okay, I think that does do a lot of the work for you. Okay, okay. So I guess I will try this problem first. Ashka, if you want, you can try that second one now that you've seen this, but if you get stuck, or if you don't want to try it, then no worries, I guess. But I guess there aren't that many steps after that Ben gave, I think. So X. You're trying to, but you're kind of lost. Okay, that it was a bit of a trickier one. You should get those functions are inverses of each other, x cubed and cube root x. So you should get one for each of them. But yeah, there's some weird exponent rules happening that I can explain. Cube root, right? There's a little 3 there. It's the same thing as a 1/3 power. Is it A? It should be a cube root, if that's what you mean. Is it a final? I'm not sure you're asking with that. I'll go through and explain it in a second. I think with this, let me just try and quickly like do this part, and then it's the answer. Oh, you would say it like if you wanted to say square root x, like that's a good way to put it in text. But it's actually a cube root, what you had in that problem. And I think they normally say like CBRT for cube root. Okay, but basically they did a sub, end up with a squared minus b squared equals x minus 1, right? Yeah. And we know that a is this part, b is that part. So a squared, we just get rid of the square root there. X minus 1 over x. B squared, oops, it's minus now, is 1 minus 1 over x equals x minus 1. Okay. Well, I mean, I think this is about to clean up, isn't it? No, it's just x minus 1 equals x minus 1. I thought you just unsubbed and you get something. That actually doesn't help, does it? So what do we do instead? Check Discord? Okay. You get 2a equals that. Check again. Oh, I'm sorry. You get square root x for the final answer. I'm sorry. No, you should get, I'm sorry. I said you should get 1. You should get just x. And I can explain why in a minute. You missed a step. Equals x minus 1 over x. Okay. I think I still don't get it. I'm gonna be honest. Yeah. I don't know where the sub is going. 4-minute vid? Okay. Okay. Oh. It's gonna be the golden ratio, isn't it? Yeah. This one won't work, right? Yeah. Puts puzzles in the back of their products? Organic biodegradable. Wow. Rest in peace, booted. Yeah, no, I'm glad you gave me that because I would not have seen where the hell you go with that sub. It's just one of those funky places where the golden ratio happens to show up. That happens a lot in very weird places. I was trying to, so when I did the problem before, I was trying to do it like without the fancy trick like that because I didn't know it existed. And it did not go well for me. Okay, so Ashka, I hope you're still here. Or if not, I completely understand, but I'll just type to you in Discord afterward. If not. Okay, you are still here? Okay, cool. So for this one, r of x is x cubed, our g of x is cube root x. I'm going to do a little thing here to hopefully make the next, or the later part of the problem a bit more clear. The cube root of x is the same thing as x to the 1/3, and that's going to be important for this next part. All right, Ben, sleep well. Thanks for coming by. So let's start with getting f of g of x, or f of g, which is f of g of x. This notation always gets me. So we take our x cubed. Now we don't want x here, we want g of x inside. So I'm just going to put empty parentheses and get the cubed. So this is our f so far. And then we fill in the middle with whatever our g of x is, which is, in this case, cube root x, or I'm going to write x to the 1/3. And now this is an exponent rule. X to the 1/3 in parentheses cubed means you multiply the exponents. So 3 times 1/3 is just 1. So you get x to the 1, which is also just x for f of g of x. Yeah, so I hope that's okay with you. For the reverse, g of f of x. I keep on doing that, man. I hate that notation. I'd rather just have it this second way. And now I'm getting messed up in my brain too. G of f of x is equal to, I'm doing similar thing here, but we said with the 1/3 power in empty parentheses, so the 1/3. Now our f of x is x cubed. You see now? Okay, good. So now we have the same thing, 1/3 times 3, we just get x. And it may look weird that we get x for both of these, but that's actually supposed to happen because x cubed and cube root x are inverse functions. They undo each other. And this is actually like, it's basically the definition of an inverse function. If you compose them with each other in both ways, you should just get x back out. So that's, it feels weird, but that is the expected answer. Glad you get it now. Okay, so last one, 7C. Oh, you need to find f of f. Okay, that's kind of a fun one. So you have to compose a function with itself here. I'll copy down the problem. So it's the exact same thing I was doing here. We're just going to use the same function twice instead of two different functions. So our f of x is 2x plus 1 over x minus 2. I didn't take my cam down. Okay. And then the question is to find f of f, which is also f of x. So we're going to take our original function, and anywhere we see an x, we're going to put another one of our original function. So it's going to look very weird, but it's what we do. And actually, I didn't give myself enough room here to write. So we start off writing the original function 2. Now we've hit an x, so we need to repeat the entire function. 2x plus 1 over x minus 2. Now we're back to the original function, plus 1, over. Now we've gone to another x, so let's write the entire original function again. Now we're back to the original minus 2. So yeah, that's that's what they want there. We can simplify this a lot more, and we probably should, because usually teachers want you to simplify your answer as much as you can. So that's the hard part. That's like the trick of the question done. Now we need to just kind of get into a nicer format. I'll start by multiplying the 2 inside the parentheses here. 2 is the same thing as 2 over 1. So 2 gets multiplied into the numerator, and then times 1 times the denominator is the same thing. So I'm going to say that's 4x plus 2 over x minus 2 plus 1 over 2x plus 1 over x minus 2 minus 2. Now, obviously, this looks really ugly because we have fractions inside fractions. But we do have a nice trick here, which is these are both x minus 2 in these like little denominators. So I'm going to multiply the top and bottom by x minus 2. Which is the same thing as 1. And you're allowed to multiply by 1. So the x minus 2 on top gets distributed to this whole thing in that it will cancel the x minus 2 there. So we get 4x plus 2, no more denominator because it canceled there, plus 1 times x minus 2, which is x minus 2. Over, now we do the same thing down here. The x minus 2 cancels the x minus 2. So we get 2x plus 1 minus 2 times x minus 2. Like that. Welcome back, BC Aura. Now let's combine some like terms. 4x plus x is 5x, plus 2 minus 2 is 0. On the bottom, let's to expand out those parentheses. Yep. Combine like terms. 2x minus 2x is 0. 1 plus 4 is 5. Oh, look at that. This function is self-inverse. Who would have thunk it? So some functions are their own inverses, and I guess that's the point of this problem. Oh, shoot. What? I just hit some random... Oh, no, I think... Okay, I think I know what hotkey I hit. Okay, I was about to do something bad and hit the wrong hotkey. So we set it up with x, funny enough. And we can verify that graphically with 2x plus 1 over x minus 2. Oh, that... Oh, if you divide these, it's some just 1 over x transformed. That's funny. It's really just a hidden 1 over x, which is self-inverse. But yeah, a function... what the inverse of a function does is you rotate it around this purple line, y equals x, and you can see if you can flip it back and forth across that purple line, and it's going to look the exact same. So that's kind of, I mean, if you have to have a graphing calculator for that, but that's kind of a nice way to verify inverse functions. So this one is self-inverse because you can flip the same thing back and forth. But more commonly, you'll see something like y equals e to the x and y equals ln x. These are a bit more obviously like two different functions. Well, they are two different functions, but this seems fun. I'm glad you enjoy it. It's definitely a fun result right there. So I assume we're still working through... do we need to work through 8 and 9 here too? And you even posted a 10 after that. Okay. For 8, I definitely don't know what you're supposed to do just by looking at it. Oh, find the inverse. Okay. So yeah, that's actually kind of builds into what we were just looking at in Desmos. So the trick to find an inverse function let me just rate the original problem again. X plus 1. So a lot of times when I was a problem, when I was taught, we usually would say y instead of f of x because it's just going to look a bit cleaner for this next step. You can do the same thing with f of x though. Basically, the process to get an inverse function is you switch the y and the x and you solve it again for y. So instead of y there, we have x is equal to 1 over, instead of x, we now have y. And now we need to resolve this for y, and that's our inverse. So you could also, instead of that, say x equals 1 over f inverse of x plus 1, and solve that for f inverse of x too. But so either way you do it, it's the same, but I more commonly see this particular thing done like this. But if the way you're being taught is like that or something like that, I would do it that way. But either way, the process is going to be the same, just that's what you call them. So I want to get the y out of the denominator. I'm going to do that by multiplying each side by y plus 1. So we get y plus 1 times x is equal to 1, because the y plus 1's cancel. Now I'm going to divide each side by x to get rid of the x that's being multiplied. So we get y plus 1 equals 1 over x. And then one final step to get isolate the y, and that's subtracting 1. Y equals 1 over x minus 1. And that right there is our inverse function. If you do the same thing that we're doing in the last problems and composed, you inserted this function into that original one, you will get x back out. So it's kind of a weird, it feels weird to do it, but that's normally how you find inverse functions. So does that make sense to you? Do you want, can we do the next one? Yeah, sure. Do you know Paul Lockhart? Alex Lonza? I don't think I've heard that name, no. Swapping domain and range. Oh, that makes sense. Talis teaches. Okay, so the next one I think is f of x equals root x plus 1. So I'm gonna do my same thing here with y, just to make it a bit easier to write. Then we switch them, so that becomes x equals root y plus 1. So I isolate the y here, let's square each side, get rid of the square root. X squared equals y plus 1. And now we subtract 1 from each side to get x squared minus 1 equals y. And that's our inverse right there. So I hope that's okay. It's good with you for that one, Ashka. For the third part, I think it would be good if you tried to do that third part on your own, or at least like you gave me some question of where you maybe got stuck. Okay, yeah, sure. Just I think it's a bit more instructive if you will like try it for yourself first, and then I'm happy to like show it. Because a lot of times, like, when I was a student, things would make sense when the professor did them, and then I tried to do it at home, and it's like, wait, what do you do? Want a weird question from an 8th grade math contest? I can't also be able to do it, but sure. Oh, I see now that you messaged me, Ashka, with the last question. Okay, I'm glad we cleared that up for you. Oh, I see what you did there with the cancellation. Okay, I'm glad I were able to like fix that one for the cube one. I don't think we need these two up anymore. There was the part 10 that I can bring up in advance. Okay, so that's another one Ash could put before. Okay, we have a positive whole number n. When n is divided by 27, you get a remainder of 14. Oh gosh, we got remainders. Divided by 64, you get a remainder of 51. What is the remainder if you divide by 12? 21. Okay. Positive whole number n. When n is divided by 27, you get a remainder of 14. So it feels like is it Euclid's algorithm or something? Like n equals 27k plus 14 for some positive whole number k, and also equals You do have the answer as well if you want to. I'll probably need it. 64. I guess I'll say L plus 51. And we want to know, I guess, what the remainder is for dividing by 12. I don't know if that's the best way to put it. Like, it might be a modulus thing, which the thing's congruent to, like, the notation, like, you know, whatever number is congruent to another number mod. Whenever the congruence involved, I get scared because I don't know how to work with it. Actually, let me see what you put. Basically, if you feel any better, I was scared of the problem that Tal's just put there, so we're both scared. I don't know if my setup will be good, but okay, so we have y equals 2 to the x minus 1, and then oh, okay, so Lockhart wrote an essay called A Mathematician's Lament, which is like his take on K-12 education. Lament is based too much on techniques, not on the history and creative aspect. Oh, A Mathematician's Lament sounds kind of familiar. I feel like I've heard that be talked about. And I do think that's a valid point. Now, the setup here isn't quite right. We should have, you swap the entire 2 to the x, but it should be instead x equals 2 to the y minus 1. So the y goes up in the exponent now. And then you have to use some logarithms to solve. So I can try it again, or I can just show it to you, but yeah, it was the setup there is bad, so I'm glad that you stopped there before you went any further. Okay, let me show you the thing then. I'll put a pause on that other problem. Okay. So we had y equals 2 to the x minus 1, right? Okay, yeah, right. So then when you switch them around, you get x equals 2 to the y minus 1. Add 1 to each side, so you get x plus 1 equals 2 to the y. Now, because y is trapped up as an exponent, the only way to make it not be an exponent is with logarithms. So let's take the log, well, we can just translate this into logarithmic form. So turn as an exponential, we'll put in logarithmic, so we have log base 2, because 2 is literally the base of the exponent, of whatever it's equal to, x plus 1, is equal to the exponent, y. And that's actually our answer right there. Do you always have to cancel the like 1 numbers? Like the one that's over here? It's a part of isolating y, I guess, so don't have x or y. Yeah, so if the 1 was over there, I would leave it there, but because the 1 is here, we're trying to isolate y, and the 1 is getting in the way of that. So you're pretty much always going to have to bring it over to the other side. I can't think of a situation where you wouldn't. Yeah, Alex, if you had some thought about that, please feel free to post it. I haven't read the actual essay, but I have Suki's clip notes now. Can we go on to 9? Yeah, sure. So I'm still not sure where to go with that division problem anyway, so I don't mind just focusing on this. We got some limits for 9. Okay, so the first one for 9 is limit of x goes to 0. Six x cubed plus 5x squared minus 3x. Oops, that's not a 5. That's a 3. Over x squared plus 2x. Okay. Okay, good. Just make sure I copied it down right. So the thing we see immediately here is that we could just try to plug 0 in, or the thing that we should look at immediately is trying to plug 0 in just whatever we're given. But we have a problem because the top just becomes 0 because everything's multiplied by 0. And the bottom also becomes 0 because everything's multiplied by 0. And 0 over 0 doesn't really compute. Take an x in front and put in parentheses. Yes, perfect. We need to factor this and look for cancellations. So we'd absolutely want to take an x out front and put the rest in parentheses. So that's going to look like on top, 6x squared minus 5x, or plus 5x minus 3. On the bottom, we can do the same. Get x times x plus 2, my bad. These two x's cancel. Get 6x squared plus 5x minus 3 over x plus 2. Do you know where to go from here? Find d for the upper. We could try to do that. But actually, at this stage, we don't have that same problem with 0 over 0. So let's just plug 0 into it. Because the problem isn't the factor. The problem is to just get the limit however we can accomplish that. So here it is going to work out. because we're going to have 6 times 0 squared, which is 0. 5 times 0, which is 0. Minus 3 over 0 plus 2. So 0, 0, minus 3 is minus 3. 0 plus 2 is 2. So we just get minus 3 over 2. So that's the thing. There is another scenario where maybe we did have to factor the top and do something like what you're saying. But unless we have to do that, I wouldn't do it. Yes. No, that's a very good question. So it is, you're right, it's like x equals 0, but I would say it's not exactly x equals 0. So this is the whole idea of a limit. Let me graph the original function. So, oh, it's a funky one. Oh, we're given a nice number though. They could have given us a much meaner number here, but basically, in this case, the limit is what the function is getting close to around 0. So right here, if we zoom in, x equals 0 is the y-axis that goes up and down here. And so as x approaches, the The x arrow 0 means as x approaches 0. Limit just means like what it's getting very close to as x approaches 0. And so here we're given one of the simpler cases for a limit, which is where the function actually, or I guess it is a simple case for a limit where the function actually is defined there. So when x equals 0, well, it's not actually defined there, but okay. That's most, it doesn't graph it. There should be a hole here at -3/2. Because if you do plug in 0, you get 0/0, and that doesn't compute. We can see the function, it passes right through -3/2, which is same as -1.5 here. And so if you just, I guess I'm going to draw it properly because I feel like I'm not going to make the point quite right. If I just like zoom way into that little part that we were looking at, it should be like the function's there, a circle, because it's not technically defined at 0, and then it keeps on going. So even though if you try to plug in 0 directly into this function, you get not defined. But if you take the limit as it gets really close to 0, it's just going to be -3/2. And that's like, that's why it's like x equals 0, but not exactly x equals 0. Because x equals 0 is undefined. But the limit as x approaches 0 is defined. It's -3/2. But yeah, and so you can have some weirder situations where they might say the limit as x approaches infinity, and for a function like this, as it goes off to the right, it just keeps going up and up and up, so it's going to be infinity like back. Sometimes it'll like level off and approach a number. Yeah, sure, Ashka. Do you have an example of infinity? Okay. So I guess we'll see that when the time comes. Oh, actually, the time is now. Actually, wait, is this the third one or is this? I think this is the second one down here, right? I guess it doesn't matter, but the one below? Okay. Oh, shoot. And yeah, Talis, I'm sorry that I'm focusing more on this one, but I do prefer to do the actual like homework problems. And if I have time, I'll look more at what you posted, but I'm still not actually sure what I do right now. So actually, if you want, could you like send me the answer maybe in like Discord, and I'll just not check it until I'm ready? Unless you happen to be hanging around, but it might be a little bit because we still got a few more problems to go through on this test. Okay. So the limit as x approaches 3 of this function. So always try to plug in the number just directly and see if you're able to do it. In this case, we can't because 3 squared is 9, and 9 minus 9 is 0, and 0 in the denominator is no good. So we can't just plug in 3 directly, but we should always check and try to. So let's look for simplifications now. And what I would do here is what you suggested on that last one for the top, which is factor out an x. On the bottom, this is the difference of two squares. X squared is a square and 9 is a square. And you can factor that as x plus 3 times x minus 3. There's like a common like format where square root of the first one plus the square root of the second one times the square root of the second one minus the square root of the second one. And so now we get a nice cancellation here with x minus 3. Oops, x approaches 3. Those will go away. We get x over x plus 3. Now we've had a cancellation. We cancel perfect, yeah. Now we've had a cancellation. Let's try our limit again and plugging in 3 and see if we get something that actually works. Look at that, we don't get 0 on the bottom. So we get 3 on top over 3 plus 3 is 6, which is 1/2. So it sounds like you're okay with that one. So we can move on to the third one. What happened to the 9? Oh, shoot. I shouldn't have erased that so quick. The 9 got factored. So we had x minus 3, x squared minus 9. So the 9 went away because x squared minus 9 is equal to x plus 3 times x minus 3. And 3 is the square root of 9, which is where that came from. This is a common format for, okay, you get it? Okay, yeah. It's called the difference of two squares, at least in English. I'm not sure if it's commonly taught like that in other countries, but we have two perfect squares. You can just always factor them like that. Okay, so the third one is our infinity one. As x goes to infinity, 1 plus 2x minus x cubed. Ooh. Over is that x cubed plus 9, it looks like? Okay. So I bet for this, were you taught rules based off the exponents, like the degree on top and degree on bottom? So that's how I was taught this at first. There is maybe a different way that we could do it too. But I want to see if that thing with the rules and looking at the degrees sounds familiar. So at least in my pre-calc class, you don't really know? Okay. So let me do it without the rule way. So in my pre-calc class, it used to be like a one-step problem because we're given like a table of rules, but we can actually show what this is. Let me rewrite it so that the top is in order of the degrees. Or in order of the exponents. So all I've done is rearrange the top a little bit. And what we're going to do here is factor out an x cubed from the top and from the bottom. And I'll show you why I'm doing that will be clearer later. So x cubed gets factored out from the top. The 2x becomes 2 over x squared. And the 1 becomes 1 over x cubed. On the bottom, we factor out an x cubed. We get 1 plus 9 over x cubed. This looks really weird, but I promise that there's a point here. We're going to cancel out the x cubes. And end up with minus 1 plus 2 over x squared plus 1 over x cubed over 1 plus 9 over x cubed. So as horrible as this looks, this actually helps us when we plug in the limit. So we try to plug it into this initial thing, you get like minus infinity cubed plus 2 infinity over infinity cubed, and we don't know what that equals directly. Here, though, it's in a much nicer format for taking a limit because it's basically like we can break it into a bunch of smaller limits. And if we just to look at kind of a little like a sub problem, if we had the limit of x goes to infinity of just 2 over x squared, we have 2 a constant divided by infinity. Infinity is a very large number. And if the denominator gets really big, the overall fraction gets very small. And so we'd actually say that this approaches 0. This is going to get very close to the x-axis and just barely like level off. So what we end up with in the entire problem is either we can drop the limit now because we're taking the limit at this point. -1 just stays the same because there's no x's involved there. 2 over x squared approaches 0 when x goes to infinity for that reason. 1 over x cubed is basically the same reason. The cubed only makes it go to 0 even faster, which don't worry too much about that if you don't understand that part. But it's basically, we want in the format of a constant over x because we know that's going to approach 0. The 1 stays the same. And then 9 over x cubed will approach 0. So we end up with -1 over 1 is -1. So limits with infinity, they're kind of tricky for that reason. But that's how you handle them for a function like that. And let me know if I lost you at some point. Okay. So let me show you the graph. Two over x squared. So basically the limit as x, oh, it's even a little bit hard to see with this graph, but I'll actually zoom in. So if you look at this graph, as x goes to infinity, we're looking at how the function behaves when x goes very far to the right. You can see it starts out high and then it drops off and it like just gets closer and closer to 0. And so we say that when x approaches infinity, the function approaches 0 because it's just getting so close to the x-axis. That's kind of like the visual way of explaining it. And kind of the more like arithmetic way of explaining it is anytime you have a fraction, if the bottom is big, the entire number is small. Like a big number on the bottom means a small overall number. So I think different explanations work better for different people, but if at least one of those makes sense, then that's all you need. And the same is true for like any power of x that's positive. So if you have y equals 1 over x, the same is true. It's just, it looks a bit different, but it still goes down to 0. If you have y equals 1 over x cubed, the same is true there too. Basically, the further right you go on the graph, the closer you get to 0. So yeah, limits involving infinity are kind of weird, but you see it? Okay, good. No points line such x-axis. Yes. And so you can plug in any number, any like real number you want for these, and you'll never quite get 0. But if you keep plugging in bigger and bigger numbers, you're going to get so close to 0. You'll just never quite touch it, but the limit does becomes 0. So that's another case where the function itself and the limit are a little bit different. But yeah. The line's just approaching the x-axis, the bigger x gets. And so in limits, we'd say that the limit is 0. Okay. I'm glad that makes at least a tiny amount of sense, it sounds like. Let's get the last one. Sounds good. Ooh. Okay. You need a trick to solve this one. And I saw that discussion happening in chat about Talus's problem that I'll look at, because I don't think I'll be able to do it on my own, to be honest. I'm not good at modular arithmetic, that's what it's called. Okay. So limit as x goes to 0 of root x plus 5 minus root 5 over x. Okay. So, like always, first thing, try to plug in 0. On top, you get 0 plus root 5 is just root 5. So root 5 minus root 5 is 0 on top. On the bottom, you also get 0. 0 over 0 doesn't compute. We don't know what that means. We need to look for a trick. And the unfortunate thing is you just have to remember this. That's the unfortunate thing. When you have a square root plus or minus another square root in a limit problem like this, you almost always multiply by what we call the conjugate, which is you take whatever sign is in the middle and you flip it. So I'm going to multiply by x, root x plus 5 plus root 5 over root x plus 5 plus root 5. So I'm multiplying by the exact same thing, but instead of minus, it's now plus. And this is a trick that you kind of have to remember for these types of limit problems, unfortunately. There might be a different way. I mean, there's a calculus way to do it again, but I don't want to show you that. You probably haven't learned it. So now when we multiply these out, yeah, we're gonna have to multiply it out on top at least. So root x plus 5 times root x plus 5 is just x plus 5 with no square root. This thing over here is carefully chosen so that we get a cancellation, because we're gonna have root x plus 5 times root 5 minus root 5 times root x plus 5. So those middle two terms will go away. And actually, I'm going to actually show that out, though, so I don't like... So, I should actually show that, I think. So, the first term comes from root x plus 5 times root x plus 5. I'll do the second term, which is root x plus 5 times root 5. Root x plus 5 times root 5. So I did that times that. And now I'll work with the minus root 5, multiply it by that. So minus root 5 times root x plus 5. And then the minus root 5 times the plus root 5 will become minus 5. And what I was saying before is that basically these two terms in the middle are going to cancel because they're the exact same things that's subtracted. And then on the bottom, I'm not going to bother multiplying it out. I'm just going to say x. I'll bother multiplying it out. No, I won't. I don't know if it'll matter. I'm just going to leave it with parentheses for now. X plus root 5 plus root 5. Okay. Yes, this will work out. Okay, good. For a second I thought that I did something wrong, but this is right. So limit as x goes to 0. Now, like I said, these two terms in the middle will cancel with each other. We have plus 5 and we have minus 5, which will also cancel with each other. So we get just x on top. And on the bottom, we have the same thing. Okay. And now the x's will cancel. And we finally have gotten something we can plug 0 into. Because here we don't get 0 over 0. 1 is always 1. On the bottom, we get 1 over root 0 plus 5 plus root 5, which is 1 over 2 root 5. And most teachers want you to rationalize the denominator. So multiply by root 5 over root 5. And you get root 5 over 10. So if you're willing to bear with me for that one like trick at the beginning, after that it's pretty much all just like algebra. And again, let me know if I lost you at any part there. N is congruent to 14 mod 27 implies n is congruent to -1 mod 3. Oh. Yeah, I wouldn't have known to do that. Or like, I've only barely learned the congruent notation, so I don't know how you can manipulate it. N is congruent to 51 mod 64 implies n is congruent to -1 mod 4. So n is congruent to -1 is congruent to 11. Huh. How do I get the last? Okay, yeah, sure. Last column. Oh, with the root 5 over root 5 row, yeah. I get what you mean. Oh, what the heck did I just do? Oh, the multiplication? Okay, yeah. So if you weren't taught to do this, then maybe don't worry about it, but at least in America, teachers always want you to, they don't like the final answer having a radical in the denominator. And so you do something called rationalizing the denominator, which is multiplying by the square root over the square root. So if you wanted, you could very validly say that your final answer is 1 over 2 root 5. And there's nothing really wrong with that. But you should be aware that, at least in most cases that I'm aware of, teachers don't like the square root being down there. We ignore the 2. Basically, I'll draw it out a bit more. So if we multiply by root 5 over root 5, 1 times root 5 is just root 5 on top. And on the bottom, we get 2 times root 5 times root 5. And so I basically like kept the 2 on the outside and did root 5 times root 5. That's the same thing as root 5 squared. So root 5 squared is just 5. And so 2 times, you end up with 2 times 5, which is just 10. So I hope that makes a bit more sense. You see it now? Okay, good. Okay. Let's do the last one. Okay, yeah, so you do have that number 10. You open done? Okay. I'm not sure what that like arrow thing with the F means. It's VF? I'm not sure what VF is either. Yeah. Okay. I guess all the ones that I replied to got closed. I don't actually. I replied this one, didn't I? Uh, sure, Ashka. Oh, derivative. That could be it. Oh, if that's the case, that's gonna be it. This they don't give us easy derivatives to get through. Send you x2 the last. Yeah, hopefully we can figure it out from this. If you could, yeah, I was trying to figure out how to rotate it. This isn't. Is it as simple as transform? Ah, why are you doing this to me? Oh, I think I got it. There we go. Oh, never mind. We're gonna have to keep that up. Okay, thank you. Give you. Oh, that's a mouse. I was wondering what that was. It looks really cool. What's like the theme? I'm trying to figure it out. Like, is it themed after a game or something? Get the grip tapes for like $1? Oh, okay. Cyberpunk. Okay, that's what I was thinking. Oh, Cyberpunk, duh. It says it right there. That's cool. Uh, so VF equals something. Is it the domain of the function? Where you're allowed to plug in for x? This is a very weird way to get it, though. So Ashka, maybe like this problem is the point to figure out what you're not allowed to plug in for x, like -1 wouldn't work here. I guess it actually would work. Or isn't it the same? Oh wait, I don't see a new picture. Oh, you mean the previous message? I see what you mean now. That one was already in portrait. Okay. Oh, inverse? That does look like an inverse function, I guess. Huh. Let's look at this other one. That does look like the inverse function right there of the original. Did we do the other thing right then? So I do see like this one right here. It was already done over on this sheet here for that one. I wonder, so I guess it's the inverse function again. I wonder how it's different from the inverse functions we were doing before, though. It seems like there's some extra thing with examining the domain where the inverse is valid. Right here they said the denominator equal to 0. Yeah, I guess so, BC. Or it's actually this other log one is also done on that sheet. So I can show you how to get the inverse functions for these Ashka. The extra stuff, I'm not really sure what's being asked. So I can at least get you that far for these problems, but I might need to leave the rest, or I might need to just throw my hands up and say I'm not sure for the rest of it. So if we were to work on the first one, at least get its inverse. Hints from the second paper. I mean, I don't really know where that comes from, to be honest. DF is domain. I don't know. I guess this comes from a reformatting of what was up here or something, but I really don't. I understand up to this part with why you get y can't equal 0, because the denominator can't result in 0. But this part with the x minus 1 over x plus 1, oh, it's the original. So actually, we could find the domain of these functions, and maybe you were asked to do some extra stuff as part of those questions, like... Oh, maybe these are two separate, like... So maybe in the instructions for this worksheet, you're told to find the domain of the original function, and separately to also find the inverse of the function. Just finding the domain of the functions, I can definitely show you that. That might be it. Okay, I feel a lot more confident about that. So I think we get to ignore inverse functions for this set of questions. And if the question is just y equals x over x minus 1, and what is the domain? The domain is basically every x we're allowed to plug in. And there's basically, it depends on the function, what rule we apply. When we have a fraction like this, we can't let the denominator be equal to 0. So we can't allow x minus 1 to equal 0, which means we can't allow, if we add 1 to each side, we can't allow x equals 1. So here we'd say that the domain is negative infinity to 1, union 1 to infinity. And actually, is that the same notation that you used in your work? I should check that, because different countries have different practices with the brackets. Okay, you use the same notation as me, though. Good, okay. So yeah, as far as I can tell, that's all you're supposed to do for that. Just figure out what x's you are and aren't allowed to plug in. Does that sound right to you, or does that sound wrong? If it's this short. Grade school that much? It's like, it seemed like you're doing, I feel like, that's part where I'm not sure, so. It seemed like you're doing multiple types of problems on that one function, like you're told to both find the inverse of that function and find the domain. And then it seems like for that set of questions, you're only being asked to find the domain rather than being asked to find two separate things. Um, yeah, that's right. I think for this, it's probably better if like you probably need to ask a classmate or the teacher or something because I'm really not sure, and I wouldn't want to steer you wrong. Oh, my phone's about to die. So yeah, I'm sorry. I don't think I'll be able to help you out with this one, but I just helped you out with a bunch of the other ones. um, I'm starting to get a little bit tired of doing math. Anyway, I've been going for like 4 hours. No worries. Glad to help. Might be one more. That's all the ones that you had sent me. All right, I'm gonna check my Discord for one thing. Okay. So I don't know if I'll period. I'll see if I can do this one quick, Ashka, but I don't think I'm gonna have the energy to do all of the other ones that you might be about to send me here. This one might be simple. Well, the first one doesn't seem very simple. I don't know how you'd find the period of that. The others you got? Okay. I'm glad to hear that. I didn't see this get graphed out because I don't know if this is gonna repeat in a very clean way. Yeah, so it does repeat. So the period happens with sine and cosine functions. I mean, and others, but it's basically how long it takes until the function repeats itself. So like you can see like from 0, 0 all the way over there is one chunk. And then it repeats again, that same pattern. So this isn't how you should get the answer, but we expect the period to be something around 10. Well, okay, it's 16 pi over 5. It was the answer we expect, but that's not a good way of actually solving the problem because you're probably not going to be allowed to do it like that. I don't know how you get the period with algebra for a function like this. I normally only see it where you have one sine or cosine. Use an identity, maybe? No, I don't see what the identity would be. Or maybe, ooh, maybe use like a half angle or double angle. I don't think it's going to help you, actually, or help me. Help either of us. So the bottom one is basically just a formula. The top one, I haven't seen a problem like that before. Okay, let me just show the bottom one first, because that's a much simpler one. I don't find if I can show you the formula. Okay, so actually that's what sine. They should have an equivalent thing for cosine, right? No? It's all about sine. It's the same formula, but I just want to show it with cosine, ideally. Really? Okay. This is better. Okay, so basically whatever's in front of the x for the cosine is related to the period. So you take the number in front of the x, for sine or cosine, the same is true. You take the number in front of the x and you take 2 pi over that number, and that's your period. So if we're given cosine of 4x, we do 2 pi over 4, and you get the period is pi over 2. And we can show that with a graph. If we graph cosine of 4x, it starts at a peak, so we go down until we get to the next peak, pi over 2. So that's where it starts to repeat itself. That's the period. So when you do, when you just have a simple cosine of 4x, it's a simple calculation of 2 pi over 4. And now the sine one is weird. What does Wolfram Alpha say about the sine one? Oh, it gets it numerically. Huh. I don't see a clean way to figure out this period, so I don't think I can help you out with the first part either. I'm sorry about that. I know the answer should be, I just don't know how you get there. The second one? So yeah, that's what I was, 2 pi over 4, yes. That's just a formula that you can remember. It's always 2 pi over the number in front of x. Whenever you just have a simple cosine on its own like that. So the number from the x is 4 here, so it's 2 pi over 4, which is pi over 2. Yep, it's just pi over 2 is the answer for the period of that function. Yeah, I'm trying to think there's some really weird way you could find the period of the first one, but I don't think it's going to work out. So I think I'm just going to leave it there because I'm getting, yeah, a little like tired now. But thanks for coming by for asking questions. See, I think I'm going to call the math part of the stream there if anyone was just here for math.